Okay, we're now going to look at some areas between graphs, and we use an approach which you'll have heard of called upper minus lower for that. So let's try this one. So we're going to find the shaded area, and the curve is the function y equals x squared minus 2x plus 2, and the straight line is the function y equals x. Okay, so let's first of all find our limits, and we can do that through making y equal to y. So x squared minus 2x plus 2 is equal to x. Let's bring that over. That'll be x squared minus 3x plus 2 is equal to 0. Okay, two numbers that multiply give 2, articulately give minus 3. It's minus 2 and minus 1. So x minus 2 equals 0, x minus 1 equals 0, x equals 2, and x equals 1, so that's my limits. Okay, I'm now going to integrate between 2 and 1, and we use this approach which you'll have heard of, upper minus lower. So let's first of all identify the upper function and the lower function. Okay, so the upper function, if I go into the middle of the shaded area and travel up, I can see that I travel up to the straight line, therefore that must be the upper function. And if I travel down, I'll go to the curve, which must be the lower function. So the upper function then is x, and I'm going to take away the lower function. Now, since the lower function has got multiple terms, to make sure that I subtract the full thing, I'll put it in brackets. Okay, so between 2 and 1, x minus 2x, that's x plus 2x, that's 3x. Got a minus x squared, and minus the 2 in there will be minus 2, and that's what I'm integrating between 2 and 1. Add 1 into the power, divide by the new power, 3x squared over 2 minus x cubed over 3 minus 2x. Remember that if you integrate a constant, it becomes a constant x, 2 will become 2x, between 2 and 1. Okay, so I can now make a substitution. 3 lots of 2 squared over 2 minus 2 cubed over 3 minus 2 lots of 2, close the bracket, minus open up. 3 lots of 1 squared over 2 minus 1 cubed over 3 minus 2 lots of 1. Okay, 2 squared is 4 times 3 is 12, divided by 2 is 6. Minus 2 cubed is 8 over 3 minus 4, minus open up. By 3 over 2 minus 1 over 3 minus 2. Okay, so 6 minus 4 is 2, so that's 2 minus 8 thirds. Minus, let's change this to 6. So that'll be 9 6 minus 2 6 minus 12 6. Okay, so 2 in thirds will be 6 thirds minus 8 thirds. 9 6 take away 2 6 is 7 6. 7 6 take away 12 6 is minus 5 6. 6 thirds take away 8 thirds is minus 2 thirds. So minus 2 thirds plus 5 6. So that will be minus 4 6 plus 5 6, which will give me a final answer of 1/6 square units. Okay, let's try another. Okay, so I'm looking to find the shaded area. This function here is given by 6 minus 3 halves x squared, and this function here is given by 4 minus x squared. Okay, let's first of all get our limits by making y equal to y. So 6 minus 3 halves x squared is equal to 4 minus x squared. Okay, so that's 6 minus 3/2 x squared plus x squared minus 4 is equal to 0. So 6 minus 4 is 2. Minus 3/2 x squared plus 1x squared is minus 1/2 x squared is equal to 0. I can then multiply everything through by 2 in the equation to eliminate the fraction. So 2 becomes 4, and that will be minus x squared is equal to 0. So now the difference of 2 squares. 2 plus x bracket 2 minus x is equal to 0. 2 plus x equals 0 and 2 minus x equals 0, which will give me roots of minus 2 and 2. So there's my upper limit of 2 and lower limit of minus 2. Okay, we're going to next think about upper minus lower. So if I go into the middle of the function and travel up, I can see that the upper function is this one, and if I travel down, the lower function is this one. So let's do upper minus lower between 2 and minus 2. Okay, so the upper function again is given by 6 minus 3/2 x squared, and I'm going to subtract the lower function, which is given by 4 minus x squared. It's got multiple terms, so I'm going to wrap brackets around it. Okay, so I've got 6 minus 4 is 2. Minus 3/2 x squared minus x squared is minus 3/2 x squared plus x squared. That's minus 1/2 x squared. And I'm integrating. So a constant becomes a constant x. I've then get minus 1/2 x cubed divided by 3. And that's between 2 and minus 2. Okay, so let's tie this up first. 2x minus, well, I've got 1/2 x cubed divided by 3. So if you've got a half and divide into 3 bits, that will be 1/6 x cubed between 2 and minus 2. I'm now ready to sub in. 2 lots of 2 minus 1/6 of 2 cubed minus open up. 2 lots of minus 2 minus 1/6 of minus 2 cubed. Okay, 2 2s are 4. Minus 2 cubed is 8, and that's going to be 8 over 6. Close the bracket, minus open up. 2 lots of minus 2 is minus 4. Minus 2 cubed is minus 8. Minus 8 times minus a 6 is plus 8 over 6. Okay, I can now simplify that down to 4/3. 4 minus 4/3 minus 4 plus 4/3. 4 can be written as 12/3, so 12/3 minus 4/3, close the bracket, minus, open up, minus 12/3 plus 4/3. Okay, so that's 8/3 minus 8/3, which is 8/3 plus 8/3, which is 16/3 square units. Okay, let's try one more when we've not been given a visual of the graph. Okay, so we're going to look at the function 7 plus 6x minus x squared, and another function which is 3x squared minus 5x plus 4. And the question is asking to find the area enclosed by these functions. Okay, now a problem that I've got here is that I don't have graphs to identify the upper and the lower, but I can work that out. First of all, this function has a minus x squared, which means it must be concave up. And this function is positive x squared, which it must be concave down. Now, if you've then got a concave up and concave down pair of curves, we can see that if they start to interact with each other and intersect, then the upper function will always be the concave up curve and the lower function will be the concave down. So we can identify that the concave up is the upper function, and that is this one. And the concave down would be the lower function, which is this one. Okay, next thing is I need to find the limits by making y equal to y. So 7 plus 6x minus x squared is equal to 3x squared minus 5x plus 4. Let's make the thing equal to 0. Okay, so I'll bring this stuff across here. So that'll be 7 plus 6x minus x squared minus 3x squared plus 5x minus 4 is equal to 0. Okay, so 7 minus 4 is 3. I've then got 6x plus 5x, which is 11x. And then minus x squared minus 3x squared is minus 4x squared. Okay, I can now change all signs. That's multiplying through by minus 1 to get 4x squared minus 11x minus 3 is equal to 0. Let's factorise that. Two numbers that multiply give minus 12 and add together give minus 11. That's minus 12 and plus 1. Okay, the second bracket cannot be factorised further, but I can take out a common factor of 4 here, which brings that down to x minus 3. X minus 3 is equal to 0, and 4x plus 1 is equal to 0. X equals 3 then, 4x equals minus 1 quarter, 4x equals minus 1 rather. And x equals minus 1 quarter. Okay, so my limits then are 3 and minus 1 quarter. Okay, so here's a visual as to what that might look like. And we need to find the area enclosed. So again, the concave up given by the minus x squared term would be the upper function, and the positive x squared term would be the concave down, which would be the lower. Upper limit of 3, lower limit of minus 1 quarter. Okay, so the upper is, as we can see, 7 plus 6x minus x squared, and they're going to subtract the lower function, which is 3x squared minus 5x plus 4. Okay, so let's tidy that up. 7 minus 4 will be 3, 6x minus 5x is plus 11x, and minus x squared minus 3x squared is minus 4x squared, and I'm integrating that. Okay, so integrate 3 becomes 3x, 11x squared over 2 minus 4x cubed over 3 between 3 and minus 1 quarter. Okay, so 3 lots of 3 plus 11 lots of 3 squared over 2 minus 4 lots of 3 cubed over 3 minus open up. 3 lots of minus 1 quarter plus 11 lots of 1 quarter squared over 2 minus 4 lots of 1 quarter cubed over 3. Okay, so that'll give me 9 plus 3 squared is 9 times 11 is 99, 99 over 2. 3 cubed is 27 times 4 is 108 over 3. Minus open up, and that's minus 3 quarters. 1 quarter squared is a 16th. 16th times 11 is 11 sixteenths. 11 sixteenths divided by 2 is 11 over 32. And 1 quarter cubed is 1 over 64, times that by 4, and that's 4 over 64, which is 16th. 16th divided by 3 is 1/48. Okay, definitely a calculator would be required here, and hopefully you would get 22 and 85 over 96.